Today we will be doing crystallization of sulfanilamide. Sulfanilamide structure is this. One of the oldest drug is a sulfa drugs. It's an antibacterial, okay, known in 1900s. Sulfanilamide. So we'll be crystallizing the impure sulfanilamide in ethyl alcohol. That is the experiment. It's a technique we are going to learn. Okay. So why alcohol? It is not that we chose alcohol randomly. We tried a lot of different solvents. If you look at the structure, it is polar, right? It looks polar because it's all the oxygen, nitrogen, amino group and all those things. So naturally you have to choose a polar solvent. And why alcohol? The reason is it is a moderately polar solvent and the compound is sparingly soluble. It is not highly soluble, sparingly soluble. And also its boiling point range is good. It boils around 78 degrees. It's less expensive. Okay, that is why we are choosing alcohol, ethyl alcohol. Now look at the solubility here. At 0 degrees centigrade, about 14 milligrams of sulfanilamide dissolves in 1 ml. At room temperature, about 24 milligrams dissolve in 1 ml. But at the boiling point, alcohol 78 degrees, it dissolves about 200 milligrams. Okay. So today we are using about 400 milligrams of this sulfanilamide. That means we need about 2 to 3 ml of solvent. Look at this. So if you dissolve the compound at boiling point and then cool it down to room temperature, you will have this much difference of solubility. That means you can recover a lot of compound, right? That is very important, this range. Solubility range at room temperature and at boiling point. Okay. Now, what is crystallization? For crystallization, maximum amount of solute is dissolved in minimal amount of solvent. So maximum amount of solute in minimal amount of solvent at boiling temperature of the solvent. That means you are preparing a concentrated solution at boiling temperature. Okay. So now let us do the experiment. Start the experiment. I will show you how to do the crystallization, right? So these are called Erlenmeyer flask. They come in different sizes. Erlenmeyer flask is good for crystallization because you can put it on the hot plate, you don't fall down, and also it is narrow neck, so minimizes the vaporization, right? Now I have already weighed 400 milligrams of sulfanilamide. So I'm going to transfer that into this Erlenmeyer flask. And before this, because it's impure compound, you better take a melting point of this compound. Okay, record the melting point. It's supposed to be about 10 degrees less than it is reported melting point. Then it's impure, right? So how do you take melting point? We already showed that, you take a small capillary, this capillary, and then take the melting point in the melting point apparatus and all those things. You already know how to do it. So taking melting point is the first thing because you need to know the difference. Now, as I said, this is alcohol, ethyl alcohol. I already taken alcohol in this reservoir. I'm boiling this in the water bath. This is my water bath, okay, to boil the alcohol. The reason is if I directly boil this here, you can do it. It's already hot plate, right? The hot plate can go much higher temperature. You don't want that. So you have no control how high it can go. I mean, you can regulate here, but still. So if you have a water bath, water boils at 100 degrees, so it cannot go more than 100 degrees. Alcohol boils at 78 degrees, so it's perfect. So this is now already, let us see the temperature here. Yeah, it's already kind of hot. 70, yes, It's already 75, okay? So I'm going to transfer this 1 ml pipette, a posture pipette. So I'll first let me add this alcohol a little bit. So you have to dissolve in a minimal amount of alcohol, and what at boiling temperature, right? Yeah. So I'll add 1 more ml. Let me see whether it can dissolve. Okay, as you add it, it cools down, so you have to again warm it up. Right? It is not dissolving. It's almost like 1.5 ml now. It may need a little bit more solvent. So the idea is to dissolve maximum amount of compound in a minimal amount of solvent at the boiling point. If you don't swirl it, it bumps. So idea, you can always put a boiling chip inside. I'm not going to do that. So let me add a little bit more alcohol. Yes. Let's see. Add more alcohol. You can see it is dissolving now. It's getting thinner. Sometimes we have crystals, then it takes a little bit more time to break the, okay, you can see almost dissolved, right? Yeah. So you can see this here. You can see it's almost dissolved. Let me take. There's 1 crystal. Because it's crystalline, it takes a little bit more time. Okay? Yes. So this is a clear solution now. Okay. Okay. So now I'm going to keep this here. You can see this clear solution. Dissolve. It's alcohol. I'm going to keep it here for crystallization. So when it crystallizes, can you come here? When it crystallizes, you don't want to touch it. The reason is you don't want to disturb the crystals. So it will crystallize by itself as it cools down. Hopefully. See here, the crystals are forming. Already it's a beautiful, it's so quick. It's not even room temperature yet. Okay? So I don't want to disturb too much. So you can see the crystals forming. It's dancing actually, kind of crystals. So you can see it moving around, right? Yeah, okay. So we'll wait for some more time and then we filter this. For filtration, we have a setup here. This is called Buchner funnel, right? And this is the filter flask. This filter flask looks like an Erlenmeyer flask, but it has a beak. And this is connected to an aspirator here, water aspirator, because when you turn the water on, it gives a slight vacuum. So that is what we are doing. So you take the crystals and filter in this. Actually, I'm not going to filter it, but I just want to show you. You just swirl and dump it here, collect it on the top. Why I'm not really filtering this? Because then I had to wash this and we are closed, so because of COVID, and we don't have facility to wash all those things and time. So what we do in the next step, we take those crystals and dump it here on a filter paper, then you transfer that into this paper, collect it, take a melting point. I will come back again. Okay, so the crystallization is complete now, right? So you can see the crystals settling down, everything. So it's ready for filtration. It's already room temperature. Now, if you want more compound to be recovered, you can cool it in cold water. Okay, that is one option. But you don't want to because it's a good recovery here. So before you filter it, what you do, you dislodge all the crystals, the spatula. See now, you can see all the beautiful crystals actually. Can you see that? I don't know how, hope it's coming well. And if you don't do that, what happens? Your liquid goes in the flask, whereas your compound stays back. So what you have to do is, when you filter it, you just swirl it, and as quickly as possible, dump it. And then, once you are done, you take a little bit of alcohol here, in this, from alcohol reservoir, and wash the crystals with alcohol, a minimal amount of, maybe, okay, cold alcohol. So then your compound is ready. You transfer that into your flask here. I mean this filter paper, everything, and you take a melting point. Now your melting point should be at least whatever is the literature melting point. So if it is less, that means now still it is impure. If it is the pure compound have a sharp melting point, and you get the right melting point, whatever I called it, right? So that is an indication that your compound is pure. Okay.